Alrighty, so I've been getting a lot of questions regarding this problem. It was one of the practice ones on the multi-view practice problems. Definitely harder than what I would expect to see on any of the quiz variants, but figured very least worth going through it. So this one was asking about identifying each surface on this object. So we're gonna do our best and see what happens. Can almost guarantee I'll make a couple of mistakes here and there as we're going through it, but hopefully we'll catch those as we make them. And should be interesting. So, step one, whenever you're doing one of these sorts of surface ID problems, oh, and the prompt for this one is we want to identify the type of surface that each one is, and in the process, we're probably going to match them up as well. But first step, we want to draw in our miter lines, so we'll just Microsoft Paint a few of these in here, nice and easy. Bit chonky. Can I? Oh, change thickness. Cool. All right. Yeah. So I'll draw in some miter lines. So once again, horizontal line from the back of the top view, and then from the front of the top view, and then vertical lines from the front of the right view and the back of the right view. And then we've got a diagonal line that goes 45 degrees between the two corners. Heavily recommend you use a ruler when you're doing this. Makes things so much easier. So, start easy and then work our way up. So first one, let's do this rectangular surface that we've got on the right. So when it comes to doing these sorts of surface ID ones, starting on the right side of the object tends to be a bit more convenient because then we've got a direct look at that face in the right view, and we don't have to worry about things being obscured, so we don't have to be as concerned with hidden lines. So we'll just label this one A. Yeah, good enough. And then we want to identify that in the front view and the right view. So a good first step is to draw in some guidelines going straight down. So we're looking for a face, or we're looking for something in the front view that's between these two guidelines. And if it's a normal face, we would expect to see a horizontal line. If it's an inclined face, we would expect to see either a four-sided shape or a diagonal line. And if it's an oblique face, we would expect to see a four-sided shape. So I don't see any four-sided shapes in this area that are purely defined by the edges of our object. I don't see a diagonal that sort of starts and ends cleanly within our line pairs. So that then would imply that A needs to be a horizontal edge or a normal surface. So let's color code. See, can I do that? That's crunchy. All right. Yeah, we'll color code it. So green is normal, and see that would be that one there. And then we've got normal face for that horizontal there. It perceivably we could also try to see if it would fit for down here, but since we know that the face is constrained by the edges on the sides of it, uh, there's got to be some change in surface going from this rectangle to the adjacent rectangle. And if we have it at that face down there, then the only other thing that's sort of associated with it in this area would be continuing along on that horizontal line, and that then could cause some problems. If we want to say that this face would be represented by that diagonal, or that, sorry, skipping ahead, by that hidden line there, then uh, that would sort of lead to the, all right, well then what's going on up here that's allowing for that hidden line? So that's a normal face, matches up with that edge there, and then following to our right view, let's draw in another guideline. So that hits there and then bounces off of our off of our diagonal line and goes down this way. So we would be looking for a horizontal line at the same horizontal that then would overlap with that portion of our object. So we'll draw in that last little green edge here. Cool. Next up, let's do this larger rectangular face. So continuing along, we've got, oh, oops, that one, drawing in our guidelines, going straight down. So we could do that as this horizontal that goes cleanly between them. Could also be a surface that we'd be looking at. So it'd be trying to find a four-sided shape that's purely between those two guidelines. So for that, we do see that we've got this shape that's partially obscured. So we've got some hidden lines representing part of it. So it could also be that as a surface. We don't know, or we don't have enough information to make that distinction just with the top and right view, or top and front view, but we can bring in the right view. So we'll draw in our reflection line once again. So following over, hits our 45 degrees, bounces down. We know that we're looking for a face that goes between the back of our object, so following the top guideline, and something that then follows this new guideline. So if it's a rectangular surface or something with four corners and four edges, then that would mean that it could be an oblique because we would then pair it with this face here and that face to get three surfaces. It could be a diagonal line, so that could potentially be this one here as that hidden line, and that would tell us that it is an inclined surface, so diagonal line, surface, surface. Uh, we could make the presumption that it is a normal face up here, and if that's the case, you would have a normal face coplanar with another normal face. So if we make that assumption, that would tell us that we have this face on the very top of our object, right next to a separate face that is also on the very top of the object. And that would then require that we have two faces that are coplanar and touching each other, which does not make sense because then why do we have an edge separating them? So it can't, or if it is a normal surface, it can't be that top edge. We could try to claim that it's this normal face here. So then, or that it would be a normal face represented by that line there. So then if we pop over back to our right view, we would be looking for something along the same guideline, horizontal line in this area, because that would be between the guidelines that we drew in from our top. We don't have that horizontal line there, so that pretty much allows us to cancel out this face cannot be a normal face. It could, however, be an inclined face because we do have that diagonal line there. So this would effectively look like we've got a rectangular surface sloped down on the back of the object. And from what we can tell, we've got these hidden lines to represent some cutout that's going into the back face. We've got the rectangle there, so surface, surface, then inclined diagonal. So that to me seems like a reasonable approach. So we're going to color that, let's do blue. There we go. So we'll do blue for inclined, and we'll figure out something else for oblique. All right, let's see. So that one's an inclined face. Can fill in this as well. So we've got inclined surface as these hidden lines and the back of our object. This is going to get very cluttered very fast, but we'll just undo stuff as needed. So that one's that one. Cool. Next up, we've got another one of these triangular faces, or rectangular faces up on the top. So this one's very similar to the previous one that we did, the first one. Um, got a rectangle there, Following our view down, we've got three options, pretty much. It could be somewhere on the top of our object, which would be allowed because now we've got a gap between our two. It could be this horizontal line there, sort of following our invisible guidelines down. Could be this one here. We don't really know necessarily, just from looking at the top to front. However, following along to our right view, we're looking then, if we want to claim that it's a normal surface, which would make the most sense, because we don't have any rectangular faces in the area that would allow for it to be inclined or oblique, or that would allow for it to be oblique. And we don't have any diagonal lines that would allow for it to be inclined. So probably a normal surface. Taking a look to our right view, we're looking for another one that's the same width as what we had in the top edge there. And the only two horizontal lines that we have are this one on the top and this one at the bottom. And one hint, if it's a normal surface and we're asking a question like this, it is never on the bottom of the object. Because if we could see this clearly from the top, then that would mean that there's nothing between the top of the object and the bottom of the object, and we would be an infinitely thin surface on the base of our shape. So that then would set this face as another normal surface. Next up, let's do something a little trickier. Let's do this one here. So we've got a sort of 7-shaped face on the left-hand side of our object. So first up, drawing in our guidelines going straight down. So from there, straight down, we're looking to see, is there another face that has these 6 edges that goes all the way between these two the two lines? And I'm not seeing anything. We've got a hard line here cutting off. So this face, is that a full face? Or this chunk of the face, sorry, can't be involved with that 7 shape. We don't, so that cuts out oblique. It can't be an oblique face because we don't have a matching surface in the front view. If it's a normal face, it would need to be on this bottom of our object because that's the only horizontal line we've got. So that leaves us with an inclined surface. So we'll pop back over to our blue. I think that was the blue I used, yeah. So this then going through that, we're looking for a diagonal line that matches in our front view, and the only diagonal line we have that goes all the way through our object is that one there. And then in our right view, we're expecting that this is primarily going to be obscured by the rest of the object being in the way. So we're looking for something that matches the shape in the hidden lines. So if we do a uh, quick little sketch, we know it goes from the back to the front. So we're looking for a shape that goes the entire width of our right view. And then we've got this corner in the middle. So we'll bring that over there and then bring up our other guideline there. So we're looking for a shape that has this profile with the 6 edges in the right view. And the one that we've got, it's partially obscured by some of our other lines. But if I draw it in, you'll see it. So we've got top edge there, bottom edge is probably this horizontal hidden line there. And that makes sense because that matches to the other end of our diagonal line from the front view. Then we've got vertical, horizontal, so those are sort of matching up with where we would expect those corners to be. So following that corner over, then bouncing over to our right view, we would expect that this thinner portion of the 7 fills up this area of our shape and then closes it off there. Cool. So once again, that one's primarily covered up by some of the other geometry, so we can't nice and easy show it in the other views, but it is there. All right, next one, let's do this sort of D shape. And that one, first step, checking other views to see if we see geometry that looks right. So here we've got another six-sided shape, and it lives between this edge and this edge. So following those, this one's a little hard to spot because it's very squished by some of the other geometry. But if we use our fill tool, hopefully it shows up. I'm going to pick a new color for no reasons, don't worry about it. Ah, okay, we can't paint bucket our way out of this one. All right, so uh, with that, we can see that we do have a bit of a shape going on. So we got line there, line here, another line there, and then very short little bit there, short little bit there, and diagonal line there. So that sort of fills in for that shape that we see in our top view. So in the top view, it's got that D shape. Down here, we can match all of the edges up with it to sort of create our profile. So that seems reasonable. We already know that this inclined line is being used by our 7 shape. So it can't be that exact same fit or the exact same diagonal because then why do we have lines separating it? It could conceivably also just be this diagonal here, but then we've got something else going on to fill in that geometry. So in either case, if it's an oblique surface, we would expect to see another shape similar to that in our right view. And if it's an inclined surface, it would need to be that line and the matching shape in the right view, or it would need to be uh, a diagonal in the right view and the surface in this one. So we can cancel normal out pretty quick. So let's claim that it is this diagonal line, and then it's going to have to show up as a face in our right view. So following along, using our miter lines, got left edge goes there, that goes to there. Right edge follows the front of our object, or the bottom edge follows the front of the object to go there. Then we've got another corner sort of at the tip of the shape. We've got a sort of shoulder that goes on there, matches up with that. And then we've got the other sort of boot tip on this one goes to there. So already I kind of see a shape that matches up, and that one goes there, there. We don't, as far as diagonals go, the only diagonal that we've got that goes this entire width or the entire depth would be this one that's on the top here. But then that would squish what we have in our front view, because if the surface is only this tall in our right view, it would need to maintain that height in the front view. And all of a sudden, the shape that we have here wouldn't make sense. So we can just go with the, all right, it's going to show up as a surface in our right view as well, because we don't have any other diagonals that would really make the cut, but that does end up with that surface there. So now to double check our work, if we're claiming that it's this brown inclined line, we would need to make sure that the height of the surface doesn't change across the front view and the right view. So if we draw in another guideline from the top of the surface in the front view and the bottom of the surface in the front, or top of the surface in the right view and the bottom of the surface in the right view, we would need a diagonal line that goes between those two corners because it's boxed in based on the size in the top view and the size in the right view. So we know how wide it is here, we know how tall it is here, so the height and the width would need to be consistent in the front view. And we don't have any diagonal line that perfectly matches for that size. So it can't be the brown inclined line that we have there. However, if we are going with, all right, surface, surface, it could still be the other surface that we have in that view. And that would make sense because it's sort of the only option left. So we're going to claim this face is an oblique surface. I hope that ramble made sense, but I guess we'll see later based on how many questions we get and the feedback on this one. So that's got most of this top view down. We've got a couple more. We have another sort of face that looks similarly shaped. So oops, that's this one here, where following along with our lines, we can see we've got another sort of, this one's rotated to D shape. So taking a look into our front view, we're looking for another thing that's got that sort of profile to it, that is perfectly constrained within that left edge and the right, or the middle guideline that we've drawn in, and our right edge over here. So we're looking for something that matches that profile in our front view, and we do have something. So we've got this surface here. Dip, 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 dip. So we've got that face that it could be. We don't have any diagonal lines that go that full width, and our horizontal lines that go the full width. We have the top one. Wouldn't really make sense because that would require that it is parallel or coplanar with the green faces that we have up there, at which point there should not be lines separating them. Uh, our other options would be this one here, which would make it a normal face further down, or the bottom edge. Again, we can disregard the bottom edge, nice and easy. Uh, I'm going to go with the assumption that it is an inclined face, or at least an oblique face, that matches these two surface profiles. So then as we go to our right view, we can check to see what it looks like there. So using that front view surface, going over straight to the right, we know it should be something that lives between those two lines. And then using our miter box, it goes from the front of our object to this middle bit of our object. So we're looking for a six-sided shape that is fully constrained within these, or within this box, or we're looking for a diagonal line that goes between the corners of that box. I don't see a shape that matches for that. We've already kind of described what the hidden lines in the back are doing, so those ones don't really make sense. But we do have a diagonal line that fills in nicely for us. So if we go with the assumption, top surface, front surface, right's diagonal line, then that would put us at an inclined surface. And when we try to puzzle it out spatially, that does make sense. If we see the face as a surface in the top view and see it as a face in the right view, and it's maintaining sort of the same perspective, you can imagine if you're looking at an inclined ramp, looking at it from, or a ramp that starts wide and ends narrow. If you look at the ramp from the top, you would see a trapezoid or trapezoidal shape where it's got a longer width on the top and a shorter width at the bottom. And when you're looking at it from the front, it's got a longer width at the top and a shorter width at the bottom. So then we would expect that the right view's diagonal would end up uh, going in this angle. So effectively, you see, I was just realized I was doing hand motions, but I don't have my webcam on, and that would just be distracting. So we're just going to quickly sketch up quick little trapezoid shape. So something like this from the top, and then from the front, it would maintain sort of maintain the same profile. Then from the right, we would get a diagonal line, or effectively, if we're looking at an isometric, let's see, we're going to freehand this and cross our fingers. So that's at 60 degrees, something like that. This is why I usually have a slide deck to keep y'all from having to deal with me doing random scribbles, but some sort of shape like that where it would then show up as an incline there. I guess to finish the view because otherwise it will bug me. Have a front view look something like that. Right view completes the triangle. There we go. Yeah, something like that shape. So we would expect diagonal line going bottom left to top right in order to maintain that type of geometry. Cool. So we are then maintaining our proclamation. This face, inclined surface, inclined surface. Cool. All right, next up, let's see, let's do this. Let's do the triangle next on the right. So for that one, we know it goes from the right edge to this left bit here. So going top to front, we would be looking for a triangle that spans the entire width, a diagonal that spans the entire width, or a horizontal line that spans the width. So as far as triangles go, we do have one triangle, and that is this one here. So we've got an option. The drawback with this triangle is that the corners don't quite make sense. So the triangle in the top view, we have one corner on this left guideline and two corners on the right guideline. Whereas in the front view, this triangle has one corner on each guideline and then another corner in the middle. Because the width dimension is preserved from top view to front view, we can't have points sort of jumping around. So this corner would not be a legal option for that triangle because this triangle doesn't have any points in that area. So that takes an oblique face out of the running because it can't be the only other surface that would make sense. So that leaves us with the potential of it being a normal surface or an inclined surface. So if it's an inclined face, the shape would need to be this diagonal line there. And let's run with that for a bit and see where it gets us. So we're going to claim normal face, it's that inclined line. And then in the right view, it would need to be another triangle that is within the front guideline that we have in our miter box and the central guideline that we've got there. And then it would also need to be the height of our inclined line that we drew in the front view. So it would need to be a triangle that goes fully within this box here. And for that, we've got two options. We've got this triangle, oops, this triangle in the top left. So that fills that spot, that one, and that one. So this triangle here. Our other option would be this triangle here. So there, there, then top there. So at this point, we now need to do some point mapping. And for that, we know we've got one where we've got, yeah, 1 point on this top horizontal. So following that over, we would expect to see 1 point on this line. And then we've got 2 points on the front horizontal. So we would expect to see 2 points on this line. So if it's this triangle that we've got x'd off, that one would not make sense because we've got 2 points should be on this line, but we only have one corner on that triangle. Whereas the 1 point that we've got in the back, that one we see we have two corners on the triangle, and that then would make that triangle incompatible. So if we do the top triangle instead, this one here, we do see that we've got two corners along that front guideline. So we've got the one here and the one here. Makes sense. Then we've got the one corner on the back guideline, so that would be the one there. So far so good. Now we need to map the corners through the front view to make sure. So following this down, we've got one corner on this guideline. That would then hit our inclined line on this corner. So we would need one corner along this guide. or, oh, whoops. No, that would be the two. Yeah, no, that would be the two actually. Okay. So we've got two corners here. Forgot the front corner. I did say I was going to make some mistakes. So, all right. So we got the two corners there. Along this one should match to the two corners here. So that does make sense. Got those two. And then we've got the other corner going on. Uh, yeah, the other corner then would follow this guideline. So we'd expect one corner along that guide there, which matches up to that one. Okay. All right, so that is potentially convincing that we have an inclined face, but I know it isn't. So why does this not work? Oh, got it. All right, so if this was an inclined face, we would effectively, or because it's being represented by these solid lines, so we have solid lines in the right view, we would need to be able to see this triangle effectively acting as an overhang here, where we've got effectively a new face that is, we've got this new face which is sticking up. It has one diagonal along that, so it's folded up around there, so it's kind of making a bit of a funnel shape. But then this new inclined surface, when it lines up there, we would be seeing it directly from the side. So here we can see it clearly, meaning that there's nothing going on in this area blocking our view of the triangle. So effectively we would need something infinitely thin. So we've just got this sheet sticking out along this diagonal line that we can see the top face of it and we can see the bottom face of it. And that would require it to be infinitely thin. So because of that infinite thin thing, that then would disallow for this triangle to be mapped to this other triangle and the diagonal, because otherwise if it did make, or if it did match up to these surfaces, we know what this blue inclined face is. So if it matched up for those surfaces, then it would end up requiring that there is nothing beneath it and nothing above it. And because each surface needs to separate matter from not matter, the face itself wouldn't quite work out. Yeah, that is, I hope, a convincing enough argument. It's a little shaky. This does make a bit more sense as we hit a few more shapes. Like I said, we are going into this without any prep, so hopefully that helps out a little bit. Let's see. So then this face actually needs to be a normal surface. So that I was using green. So normal face. And then if it's a normal surface, it matches to this horizontal line there, and that horizontal line there, because that then would follow the mapping. So we're looking for a horizontal line between those two. So cool. All right. If that's going on, then what's happening with this face and this face? But we'll get to that in a bit. So, alrighty, let's see. This is a mean one. All right. For our other trapezoid that we've got in the top view, this one we are then going to look for a matching trapezoidal shape in the front view, and we do see one. Let's get our colors. There we go. So, excuse me. Looking for a trapezoid between these two lines, we've got this one here. We don't have any diagonals that go all the way, and we don't have any, or the horizontal that we have would sort of be along that fuller surface there. So if it is that face, then we should be able to map over to our right view, draw in our guidelines yet again. We are looking for a diagonal line that goes purely between these two, or purely within that grid square there. And we do have one. So we've got this diagonal line there. However, we know that diagonal line was already identified as part of that inclined D surface that we have. So this diagonal is kind of already accounted for. If this was not directly connected with this D shape, then we would be able to go forward with the assumption that it matches that inclined line. However, it is directly connected. So if it's an inclined surface that is connected on multiple sides to that original plane and it matches the incline there, then we don't have two surfaces, we have one surface. So we can discount that being this face here because we do not have a trapezoidal surface that matches that shape in our right view, and the diagonal line that we have, well, we do have a trapezoidal face, sort of this bit here, but that one was a bit too wide to match up with the width that we see in our top view. So we don't have a face within the guide box that we had drawn. We don't have the diagonal line as an option because that's already accounted for. So then that means that this one cannot be an inclined face. It would need to be a normal face. So we can then color that as normal, and that would have to match up then with this horizontal there, which does mean that we've got another trapezoidal face going on in the right view, or going on down here that might cause some issues when we get to that. All right, how long have I been talking? Oh, okay, this is going to be a long one. So, let's see. Down to our front view, let's keep going. Um, we've already got a couple of these faces identified. So we have this one here. That one's already accounted for. Let's do the triangular surface. So that would be this one here. So already we know that it can't be an oblique face because we've already accounted for all of the faces in the top view. So this is going to need to either be an inclined face or a normal face. So if it is an inclined face, we would need a diagonal line that goes for the width of it in our top view. Oops. So from the right side of our object to here, we've got a diagonal line that does sort of pass through that, but that accounts for this, or the side of our blue surface there. So it doesn't quite make sense. So that would leave us then with something sort of on the inside of our object there. So that would imply that this is a normal surface sort of going underneath of our initial inclined face. So effectively we've got this, and then it produces a little bit of an overhang that would then have our triangular surface in the back of that object. So following over to our right view, we would expect to see a vertical edge that has the same height, and it would need to be positioned on the same guideline as what we would get from our top view. And fortunately, we do have this vertical edge here, which follows all of the qualifications for what we were talking about. So, normal face then for that triangle. Oh, oops, green. Next up, we've got another triangle. Or let's do this bottom rectangle first. That's easy. So for that one, we're looking for a diagonal line that would go from left to right for this guideline, or a horizontal line that goes left to right. Also, we can see it clearly from the front, so that means that there's nothing sort of blocking it as we keep going. So it could be this horizontal there. There is an off chance as well that if this is inclined or oblique, it might be going under our object. So we're going to need to check with our front view or check with our right view to see uh, if there's any geometry that would make sense for it to be undercutting. So we would be expecting to see a diagonal line if it's sort of a direct slope that would go between these top and bottom lines. However, I don't really see one of those. We would expect something like that, but we don't have any diagonals that go the entire height. So pretty safe to assume this then needs to be a normal surface. Oops, helps if I have the right tool selected. There we go. And then that normal face, because it lines up with the top edge of or the front of our object in the top view, we need to then also align with the front of the object in the right view, mapping that bit there. So we know we've got this normal face on the front of our shape. Makes things nice and convenient. And actually, if I recall correctly, it isn't just that. Dang it, I should have erased some of those earlier. It also then is this bit of our shape here. So it actually gets a lot easier if we don't have lines covering up all of our perspective. Uh, we don't see this shape in our top view, we don't see this shape in our front view. So normal face covering the front of our object. So we will just also extend that to that, and then that bumps its height to the entire height of our shape. All right, let's see. Next, let's do this trapezoid. Yeah, we'll do this trapezoid. So taking a look at our front view to top view, we do have the same width as what we had done previously, going between those two there. This one, we would be expecting to see a diagonal line or something along those lines that passes. I don't see one. We don't see another sort of face that would represent a trapezoid in this area. We've got a hidden line sort of cutting through something there. So it seems like there's something cutting in on the face of our object. But we do have a horizontal line that sort of matches up a bit further. So it can't be the horizontal on the front because that's already being accounted for with the large L-shaped surface. But it could be this one because that would be inset into our object. So this looks like probably a normal face onto the inside of our object. All right, onto the triangle. So for this triangle, we know its left side goes to there, its right side goes to there, and its middle point goes through there. So we do actually have a potential surface that it could line up with, and that would be the one partially defined by the hidden line there. Oops, hidden line there, or solid line, and this one's the hidden line. There we go. So it could match up with that triangle. So that then would position it as an oblique or inclined face. So if we draw over to check to see what it looks like in the right view, that might give us a bit more information. So we've got, that's our height. Then we know our width is, or depth is defined by our perspective on the top view using our miter lines. There we go. So we are looking for a triangle that is defined purely within that shape, and we do have one. So that would be this triangle here. So then the last trick would be doing some point mapping, and then we can do a little bit of interpretation. So just sort of comparing, checking to see if it would make sense how we would see it. So first up, we've got this corner up there. Got one point goes to the one point. Then that follows our guideline. So we would expect that we see, or Yeah, one point to one point, point to point, point to point. Yep, so all three of those corners are accounted for and they're at the right horizontal positions. Then we've got 2 points on this guideline here, which matches up with what we see in our right view. We've got the 2 points on that one. Woo, sorry. And then we've got the 1 point on the front guideline, so that matches up to that corner there. So far, so good. Then comparing directly front to right, we've got one corner on the top edge, two corners on the bottom edge. Makes sense. So if this then is an oblique face that's being represented by the hidden lines there, we would then sort of see that we've got one edge along our inclined object here. Wait a minute, am I talking myself out of this? Okay, never mind. I was talking myself into a corner for a little bit. Uh, starting with the hypotenuse at this edge here makes things a bit complicated. So let's start with this edge instead. So starting with that edge, we know that goes from that point to that point, which would be this point to this point here. So that edge maps to the back of our object and or the sort of back of this little carve out and matches up with this normal face that we've got there. So that makes sense. Then we have this edge on the left goes into our object. So that is inset by some amount and then comes out to the front. So that would make sense for that one. And then we've got this third edge, which from our front view would then need to be that bottom edge. So effectively, we've got some little pocket carved in here, and then there's an oblique face that's nestled in underneath of the overhang. And then we've got this triangular face there that's sort of the open flat surface represented on this bottom edge there. Okay, yeah, okay. I think that makes sense. I could be a little wrong on that, though. I'm trying to interpret if there's another way you could see this, and I'm not spotting it. Yeah, we're gonna go forward with that. I'll check the answer key afterwards, but this is already too long. So that caps off that there. Horizontal, horizontal matches with that diagonal line there, closing it off. Cool. Oof. All right, oblique surface, those are brown. So brown. All right, last face that we've got in our, or last two faces in our front view. We have one is this little sliver of a face that actually is what includes this hidden line there. So that hidden line going up to our top is representing this edge on the inside of that. So this little sliver of a face isn't just the face itself, or isn't the entire face. That's actually representing this whole trapezoidy shape that's on the inside behind that oblique surface that we've got there. So this then matches to that face. So that makes that little sliver of face a normal surface, so, or at least part of one. And then we've got this larger triangular face. That one is going to map, or it's not fully triangular. So we've got tiny stubby bit there, long flat bottom, diagonal going up, that closed there. So that going up to our top view, we can see it clearly. So it's probably going to have to be that inclined line there because otherwise it would have to be getting obscured by something. So that maps to our incline, which then if we go over to our right view, we would expect to see a, excuse me, another version of that face that would be that depth. And fortunately we do. We've got a little stubby bit, diagonal, flat base, and left edge. So, excuse me, within the range, four sides, we're all good. Inclined is blue. Cool. Last ones are over on the right side. So we've got that as an oblique face. It's already been sorted. Got that. We've got another oblique face that's obscured by a lot of the rest of it. Looks like, there we go. So gonna have to back up a good bit to, oops, there we go. All right, good bit backed up to see what we're doing a bit better. Draw back minor lines. Y'all can just rewind on the video to see the other options that we had there. That's that one, and then that one there. Cool. So, first up, we've got a rather large face that is sort of encompassing most of the hidden lines, so we get to ignore most of those, thankfully, because we've got giant face covers a lot of them up. So that there, another big L shape. I don't see anything that matches that geometry in the other views, and like we said earlier, uh, we already have all of the surfaces kind of accounted for the nice easy ones in these other views. We don't have any diagonal line that goes the entire height of our object in the front view or the uh, depth of the object in the top view. So this, probably a normal surface. This one already done. This bit here, we would be looking for a triangle or diagonal line that goes the height of the object, uh, or that goes this height of our object. And then in the top view, oops, draw in our 45 degrees again, we would be looking for something that goes this bit of the object. So we'd be looking for another diagonal or triangle that goes that. I don't see one necessarily. So that triangle would then have to be a normal face, probably that line there, because otherwise, or because this diagonal was already accounted for as the edge of this face there. So this triangle, if that was represented by this diagonal, we would need the triangle or another triangle with 2 points on the top, 1 point at the bottom in the front view, and sort of vice versa. For if it was the diagonal in the front view, we'd need the triangle with 1 point on the right leader and 2 points on the left leader. We don't see those, so that's got to be a normal surface. And that normal face then lines up with this bit there. That leaves us with this triangle. And following along with what we had done before, we'll draw in our guidelines. So we've got that one there, point, oops, point, point. Following our top view, diagonal, got 2 points on that, 1 point on that. This one ends up actually matching up pretty close with that same triangle that we had done before. So that triangle up here that we used for this triangle. However, as mentioned, it did seem like there was just this little pocket sort of carved out, and then that had an oblique surface down at the bottom that fills in that space, and then another sort of, yeah, the oblique surface down there that fills in the bottom corner, And then we had the larger triangular face up here that it was sort of going into the back of the object. So if we do our edge matching, let's see, we've got that corner would map to, let's see, I did say that one's a normal face. So this could also be an inclined surface. Yeah, this is an inclined face. Okay. Okay, why is it an inclined face? All right, so looking at our inclined face, if it is a diagonal, this one's already accounted for. This one could be, yeah, if it's an inclined face in the top view, it would need to show up as a triangle in the front view, and we don't have it as a triangle in the front view. But it does show up as a or it could show up as a diagonal line in our front view. So that could appear as this diagonal here. Okay, there we go, there we go. Convincing myself of the correct answers here. So we've got that diagonal, we've got one corner on our top, corner in the middle, corner on the bottom. Going to our top view, got corner on top, bounces to there, goes to there. Yep, so that one makes sense. Corner in the middle, goes to there, bounces off there, goes to there. Corner in the middle, yep. Corner on the bottom, bounces there, bounces up. Corner on the bottom, there. Cool, okay. So we've got our faces that we're identifying that way, and uh, yeah, the other triangle is already accounted for. Effectively, then what this would look like is there's a little carve out here, and then we've got an extra piece of geometry filling it in, and that is then covering up what would otherwise be the triangular face left over by that initial inclined face sort of protruding outwards. So normal face, inclined face, oblique face, normal face. And then this should all match up with the answer key. Give me one moment as I get that out. All right, if I actually checked the answer key before I started, this might have gone a little smoother, but hey, now you've heard a little bit more about the general workflow for how I approach these sorts of problems. So, checking this over, we can see our object a bit better. Nice flat surface on the side. We got this triangular face here is the oblique triangular surface that was there, and then also partially represented by the hidden lines. We can also see that we were vaguely lied to. So this pocket down here actually ends up as a rectangular surface um, because we've got this trapezoid that's effectively extrude cut into the side of it. So that face isn't just these four edges, it's actually a rectangle all the way at the bottom with an inclined surface represented by this line here, and then another normal face sort of making up the roof of that pocket. And cool. Yeah, hopefully this helps out a little bit. If anyone actually watches this thing at regular speed, why would you do that? Definitely 2x this one. But hopefully it helps. All right. See y'all in class tomorrow. Best of luck with the rest of your studying, and have a good one.